Hey everyone, this is Bhargav Sudhar, and today we are going to learn what is a relation. Now in this session we will also discuss how to construct a relation matrix and how to construct a digraph. So first let us understand what is a relation. Now let capital A and B be two sets. Now a binary relation or simply a relation from the set A to the set B, that is from the first set to the second set, it is a subset. The relation, it is a subset of the Cartesian product A cross B. Okay, so it is simply a subset of Cartesian product A cross B. Now suppose capital R is a relation from A to B, then R is a set of ordered pairs where each first element comes from the set A and each second element comes from set B. Now that is, for each pair, this A belongs to A and B belongs to B, exactly one of the following is true. So the first one is this ordered pair AB belongs to R. We can say that A is R related to B, or simply A is related to B, and it is written as this A capital R and B, and it means that A is related to B. Then second, AB does not belongs to R, then we simply say that A is not R related to B, or in other words, A is simply not related to B, and it is written as this A not R and B. That means A is not related to B. Now if R is a relation from A to itself, here it was A to B. Now suppose it is a relation from A to itself, then that is R, it is a subset of A cross A, and that is A square. Okay, then we can say that R is a relation on A. Simply R is a relation on A. Now let us discuss what is a domain and range of a relation. Now let capital A and B be two sets, and R, it is a relation from A to B. So in simple manner, it is subset of the Cartesian product A cross B by the definition. Now that is, yes, obviously R is a subset of A cross B, and this R equals to the set of all AB such that A belongs to A and B belongs to B. So that means A belongs to the left set and B belongs to the second set or the right set. Now the set of all first coordinate of R is known as domain of R. So if we combine all these first coordinates, that comes from the left set, and it is known as domain of R. And in same manner, the set of all second coordinate of R is known as range of R. So that means if we combine all the right hand side right coordinates which comes from the capital B is known as range of R. Let us take examples. So first, let A equals to 1 to 19 and 20. Okay, 1, 2, 3 and so on up to 20. Then the R is given as set of all xy such that x equals to 3y. Here the relation is given. Okay, now what will be the R? Now then R will be like this. See, x equals to 3y, so x equals to 3 times y. So whatever we take y, it will become 3 times the x. Okay, so let us take y equals to, here the A and B both are same, so and it is from 1 to 20. Now let us take y equals to 1. Then what will be x? It will be 3 because it is 3 times y, so 3 1 pair will be there. Then let us take y equals to 2. Then what will be it? So it will be 6 2. Then let us take 3, so x will be 9. Then let us take 4, then it will be 12 4, 15 5, 18 6. Now up to this it will be clear. Now if we take y equals to 7, then it will become 21, but that is not in the given set. So this is the relation. So this is how you can find the relation. Now let A equals to this 2 3 5 and 6, and R equals to given as set of all xy such that this x divides y. This notation is x divides y. Okay, then what will be the relation? It will be like this. How? See, we have 2 3 5 6, both the sets are same, 2 3 5 and 6. Now 2 divides 2, yes, 2 divides itself. Again 3 divides itself, 5 divides itself, and 6 divides itself. So 2 2 3 3 5 5 6 6 will be there. Now let us take 2. Now 2 does not divide 3, so 2 3 pair won't be there. Now in same manner 2 5, 2 does not divide 5, so 2 5 pair won't be there. Then 2 6, 2 divides 6, so 2 6 pair will be there. Now let us go to 3. Now 3 does not divide 5. So 3 5 pair won't be there. Now 3 divides 6. So it will be there. So 3 6. And same manner 5 does not divide 6. So 5 6 pair won't be there. So in relation 2 2 3 3 5 5 6 6, 2 6 and 3 6. These many entries will be there. So this is how you can find the relation. Now let us discuss how to find a relation matrix. Now let capital A equals to, the entries are given in general form. So A1, A2 up to AN and B equals to this B1, B2 up to Bn. So A and B are finite sets containing, the first set contains n elements and second set contains m elements respectively. So then this A cross B will contain n cross m elements, the whole Cartesian product A cross B. Now let capital R, it is a relation from A to B, then obviously by definition it is a subset of the set A cross B. Now to represent R as a matrix, it is known as a relation matrix, and in short it is denoted like this capital M subscript R, so MR. Now this is how we can calculate a relation matrix, that is MR. Now see, in simple manner, just write 1 if A is related to B and 0 if it is not related to B. Clear? Let us take example. Now A equals to 1 2 3 4 and B equals to 1 4 6 8 and 9, and A is related to B if and only if this B equals to A square, then find the relation matrix. Here the relation is given as B equals to A square. So first we will find, or we will write the relation, and then we will proceed for the matrix. So the relation will be, what will be the relation? See, 1 1 2 4 3 9, it will be it. See, B equals to A square. So first element square is the second element. So 1 1. So 1 square equals to 1. So it is there. Now 2 square, that is 4. So 2 4 pair will be there. Now 3 square, 9. So 3 9 pair will be there. Now see, in A we have 1 2 3 4. So we have taken 1 2 3. Now 4 square equals to 16. But 16 does not belong to in that B. So that pair won't be there. So in short, this R contains 3 pairs. Okay. Now see how to find matrix. So this will be the matrix. Now see, A has how many elements? That is 4, and B has 5 elements. So in matrix, the number of rows will be 4 and the number of columns will be 5 according to the order of A and B. So it represent like this. See, first row represent 1 2 3 4, and this 1 4 6 8 and 9. Again, this row represent 1 2 3 4 and column represent 1 4 6 8 and 9. Now see, we have relation, in relation only 3 entries are there, so that is 1 1. And now you can see that this 1 1, so it is 1 1, that means 1 is related to 1, just simply write 1 there. Then 2 4, so that means 2 4, so simply write 1 there. And 3 9, so simply write 1, and except all this we have write 0. Now what is a graphical representation of a relation, or in short a digraph? Now let capital A be a finite set, and let capital R, that is a relation defined on A. Here both the sets are same, so it is a relation defined on A. Then R can be represented by graph, and it is called digraph or directed graph, but we will use digraph more. Now the elements of the set A are represented by circles or points, and these elements are known as nodes or vertices. So in short, these elements of the sets are points or circles, and we call them as nodes or vertices. Now if A is related to A, okay, we have two conditions. If A is related to A, then this can be represented by a loop around, we will see. And if A is related to B, so that means see, A is related to itself, then we will use a loop. Now if A is related to some other point, some different point, then this can be represented by an arc as edges, and it is known as edges from A to B with an arrow from A to B. Now let us check. See, take one point A and let us take name. If A is related to A, then we will draw this type of loop with this arrow. Okay. Now if A is related to B, so for that we will have to consider 2 points. So that is, let us take A and let us take B. Okay, now A is related to B, then we will draw this type of arc with the direction this. So find if A is related to A, so then there will be loop, and if A is related to B, then there will be an arc. Let us take one example. If A equals to 1, 2, 4, 8, now A is related to B. If A divides B, then find the digraph of a relation. So we have given A, if A is related to B, if and only if A divides B. So the device relation is there, and we want to find the digraph. So first we will write what is a relation, okay, then we will proceed. So here the relation will be, see, 1 divides, each and every element divides itself. So 1 divides 1, 2 divides 2, 4 divides 4, and 8 divides 8. So 1, 1, 2, 2, 4, 4, 8, 8, they will be there. Now consider 1. Now 1 divides 2, 1 divides 4, 1 divides 8. So 1, 2, 1, 4, 1, 8 will be there. Then let us take 2. 2 divides 4, 2 divides 8. So 2, 4 and 2, 8 pair will be there. Now take 4. So 4 divides 8. So that's it. So in R, these many entries will be there. Now how to find or how to draw this digraph? Now we have, how many points are there? We have 4 points. So first, just take 4 points. 1, then 2, then 4 and 8. Okay, we have taken 4 points. Now see, 1, 1, 2, 2, 4, 4, 8, 8. So that means they are related to itself. So the self loop will be there. So this is how we can draw self loop. So 1 is related to 1, 2 is related to 2, 4 is related to 4, and 8 is related to 8. Now let us take 1, 2. So 1 is related to 2. So 1 is related to 2 by this arrow. Then 1 is related to 4. So this arc with this arrow. Now 1 is related to 8. So this arrow. Now let's go for 2. So 2 is related to 4. So that means 2 to 4. Then 2 is related to 8. Then 2 to 8 with this arrow. And last 4 is related to 8. So 4 to 8. So this is how you can draw a digraph. Thank you.